Hello everyone, I'm happy to see you in our next video that will be devoted for further updates to the methods that we can do in Java. So we're going to look at section 3.4 where we will look into, we will revisit methods and we'll look into returning and overloading in methods. Okay, first thing first, we're going to look into return methods or value methods. And to do so, let's actually dive right straight into our Eclipse. Let's create a new section, a new package under name section 3_4. Within this package, we're going to create a new method. We're going to create a new class. We're going to call it value method demo. Finish. By default, let's declare our main method. And before we jump into creating our custom value method, let's remind ourselves a few value methods that we saw coming from Java libraries. Best example would be our math class. So we said math class has methods that will help us to work with numbers. One of these methods is going to be math.max when you pass in two values in today's math method, like two integers, number 5 and number 3. We said it returns the larger, whichever is the bigger. Now, when we leave it as is, it can be, this program will not do anything. When we put this method, when we indent it or nest it inside our print line statement, system print statement, what happens is we get to print number 5. So in all of our methods before, up to now, we never had a method that we could ask to be called inside a system print line statement, right? So just let's go back. Let's look into one of our methods. We have under compound, we had a method called limit55, right? When we get back to it, we said that limit55 accepts an int as a parameter that's going to be speed, and this speed is going to be checked against the limit of 55 miles per hour, and it will print out whether it will change the value of the speed and print out current speed. Okay, so we know how to call a method from another class. We need to import package name. So I'm just going to copy this package name. I'm going to say create an import statement, import package called section 3_3, and we're going to have an issue here. Let's see what this error message reads. Always read the error message. Okay, now, and we know that when we are importing a package, we need to say which class from this package we are importing. So double click on compound demo and we can get rid of extra semicolons. So it is not complaining now, it's just warning us that it has never been used. So we imported this class from section 3_3, but we never used it. So let's go ahead and keep this math method here and try to do the same and call our compound demo dot limit55 and pass a speed 50. So if you remember from before, when we pass a speed of 50, it will increase the speed itself to 55 and print out 55. However, we have an issue. It says that the method print line boolean in the type print string is not applicable for the arguments void. What does this mean? It means, let's go back to our method signature. This is the method signature. When we declare our method signature, we say public, static, we'll get to these two, and we also say void. However, if you look at math.max method's signature, which we can do by hovering over and reading the documentation, scroll down. Okay, let's actually hover over and open up. Yeah, here, this is the documentation. Look at the signature. It says public static. This is exactly the same as our method. Instead of void, we have int. Void means this method is not going to return anything. Int means this method is going to return an int value. So that's why when we say that when we call this method and pass in 5 and 3, it is going to return the higher, the bigger one, which will be 5. However, our limit 55 method does something inside similar to what max does. It runs certain statements inside the method, but it does not return anything outside. It does operations inside, prints out. However, it doesn't return anything outside. And for our print statement to print out anything, we need to give it a value. Even if it is 5, it needs to have a value to print. So up to now, we have developed methods that do not return anything. We have developed methods that do something within, run certain operations, achieve something, and just to see whether we have been doing the right thing, we have basically added print statements inside our method. However, this time, what we're going to do, we are going to replicate math.max method, and we're going to call it bigger. For example, naming doesn't matter as long as it makes sense. So let's define our method signature. Public static remain as is. Instead of void, like we did with all our previous custom methods, and like we do with name method, we are going to put here a type. It can be any type. I repeat, it can be any type. Right now we know 8 primitive types and 1 non-primitive type. It can be any one of them and any other non-primitive type, which we will see in the future. For now, let's just keep it simple because we're trying to replicate math.max method. And this method of ours is going to be called I'm sorry, not math, but it's going to be called just maximus. And the same, similar to math.max method's signature, we're going to accept one int, num1, and another int, num2 as our parameters. And let's not confuse it with math.max. Let's call it math biggest or largest. Cool. And here, let's continue. The moment we type this, we have, and also don't forget your documentation. Don't forget your documentation comments, or Java doc comments. Now, when we do this, the moment we declare our method and signature and open the method block, it starts complaining. Whereas in our previous cases, even in the case of a main method, it never complained. We can have main method empty. When I comment this out, there is nothing to run inside the main method. However, it's not going to complain. Why does our return method complains? Simply because when you are creating a return method, if you hover over, it says that this method must return a result of type int. Here comes our first rule. You have to return something. And this something has to be whatever you promised that you're going to return. So actually, in this section, we're actually going to look into 2 things within one video. We're going to look into creating value methods, return methods. Also, we're going to look into the common errors that are done when creating these value methods. Okay, so rule number 1, if you have declared a return method, you have to return something. Rule number 2, if you declared a return method that you're going to return a certain type of data, you have to return that type of data. So if you said you're going to return apples, you have to return apples. No apples to oranges. Okay? All right, now let's proceed and let's create a simple method here. So it is a common practice, and it's a good practice to, as soon as you declare a value method, return something that will not make sense. Usually, when it's an int, we return -1. If it is, so basically we return a negative of a default value. If it is a string, we return null or empty string, or any kind of a NA, not a string that contains NA. If it is about numeric variables, we return -1 because we will change this later on. Okay, now, as soon as I added a return statement here and I added a value of the same type as I promised to return, our compiler stopped complaining. Now we can continue coding without issues or by catching our own issues. Before we continue, I want to pay your attention to this return statement. In our previous methods, we saw return statement as such, and we always said that the moment compiler touches the return statement, it is going to drop everything and run. The same applies to value methods or return methods. However, this time, the moment compiler sees return method, return call or return command, it will drop everything, look into what we are asking to return after this command, and will return that. It can be a number, it can be another method call, it can be anything. However, we will drop everything before and everything after, and we will look into only this, whatever the expression is before our return statement is complete. Okay, so in this case, we're returning just a number. You can return math.max bigger of -5, -1. It does not matter. Okay, but for the ease of read right now, we're not going to confuse further. We're going to just return -1. This will stop our compiler from complaining. Now, inside this method, what we're going to do, we're just going to go by take a simple route and create a local variable called int largest. We're not going to assign anything to it at this stage. And then we're going to create a regular if-else statement. If number 1 is greater than number 2, largest is equal to number 1, right? Simple condition. If the number 1 is greater than number 2, largest is number 1. Else, largest is number 2. Otherwise, number 2 is largest, correct? Then, instead of returning -1 now, we are going to return whatever the value of the largest is going to be. So, largest is going to be equal to number 1, or it is going to be equal to number 2. And whatever it's going to be equal to, we're just going to return that. Before we proceed any further, let's actually create our call here inside the print line statement. Since we are replicating math.max method, we are just going to put them next to each other, and we're going to use exactly the same variables to test our method. And following a good test practice, we're going to do this. Test values, we're going to create test values, 5 and 3. We're going to do -5 and -3. We're going to do 0 and 5. That's it. You can create as many test values as you would like to. These test values addresses some of the scenarios, and we're just going to keep it there. Now, when we use first set of test values, 5 and 3, both for math.max, also for our custom largest method, when we run this code, what happens is it's going to print 5 both times. What if we do -5 and -3? So we trust math.max method. That's why we use it as a benchmark to test our custom method. So if I do -5, -3, our largest amongst the two is -3. Our method works just fine. Now, this is basically a simple demo of a method that returns value. Again, couple things. Return value can be of any type. If you said if this method is not void, it has to return a value. It cannot contain just a return statement without any value. We created basic if inside. We created our local variable, and we just created basic condition. You can achieve this in a single ternary, and I will go even further, saying that you can create a ternary right here. So pause this video, try your knowledge, remember ternary statement, and I can tell you that this once return can have the answer right away. If you want to take a shortcut, let me actually give you another idea. Instead of returning the largest and writing all this code, since we have math.max method, just call it. Okay, all these libraries that Java provides are there for us to use. It is not going to be taking a shortcut. It is not going to be cheating. It is actually going to be a smart move in this case. This is just to demonstrate how methods can return values. Having said all of these, and before moving on to the next very interesting and very important topic on methods, we need to show you, we need to repeat that return methods have to return a value. Remember rule number 1. Now, there are certain cases where you can have this if-else condition and you can fail to return something. Now, to demonstrate that, let's create another method, public static int demo return. We're gonna take int number 1. We're just gonna take one number. Okay. Now, automatically, well, let's not do the default approach of coding. Let's say you're confident and you don't return anything, and you start coding. You say if number 1 is greater than 0, right? Return, by the way, you can add return statements here as well. Return 5, for example. Else, if number 1 is less than 0, return 3. Let's say you're given a task where you have a task that says if the number is positive, return 5. If the number is negative, return 3, for whatever application that might be. And you, as a developer, you just checked for number 1 is greater than 0, number 2 less than 0. Or let's actually, this is obvious that there is something we're missing, and you just checked, this is perfectly fine code. You just return 3. Now you checked for higher value, more than 0, and you checked for less than 0, and you thinking to yourself that if the number can be more, number can be less, and for both cases I have a return statement. Why is my code complaining? In this case, compiler is going to catch cases where simply the number can be equal to 0, and in this case, let's say you're told to return 0. Now, I'm sorry, num1. Yes. Now, you see, this method must return a result of type int, and the question is, why is our code failing? Concept here is that we have to make sure we return something. If you have 3 if statements like these, there might be cases where your code does not return a correct value. Simply stated, compiler is automatically programmed to make sure that if you have an if statement, you have an alternative. Either that if statement is closed by else condition, or outside if statement you have a return. Even though in real life a number, an integer, can be either greater or lower or equal to 0, compiler does not see it that way. Okay, so for compiler, this method here has 3 conditions that are independent, and there might be a 4th condition that this value is not going to be, these conditions are not going to be met. So your choice is either at the end of the if conditions return a number, even though this will in the real life will never be met, right? Or add an else statement to your last if. Else return, for example, 0. So if you comment this out, so compiler says thinks that this if method cannot be met. This if method may not be met. But when the compiler sees that there is the last if method has an else statement, it means if I'm going to get into this statement, then even if this might not be true, then I'll definitely get to this part. Usually, this is not a good practice. Usually, you will either have if-else if branching, with else at the end, or you will have simple if complemented with a return statement like this. You're going to check for one condition, and if that condition is not true, you can write an else, but there is no need. Return here will do the job of an else. Or you will simply have a ternary on a single line. So make sure, which compiler also tries to, make sure that you return a value. Another error can be for the cases where you're going to run into a dead code. Going back to our previous example where we said an else condition will do just fine. When you do this, see what happened. Compiler started complaining that this code is unreachable. And we have seen this before. We always keep repeating that the moment compiler sees a return statement, it will drop everything and run. If the statement has a value before the end of the statement, the compiler will drop everything and just return that value. It will forget whatever happened. So in this if-else condition, when the compiler gets into this block, right? When the compiler gets into this if block, it knows that it is either going to be returning something from this block, or if not this, then it is definitely going to return this. There are no other options. So this code here is dead. It is not reachable. So it is known as unreachable code or a dead code. Beware, because this has nothing to do with the value methods rules. This has something to do with writing a code that is unreachable, because compiler warns you that you might have a very important logic here. This logic is not going to be reached. Your compiler warns you that you're missing something, or your line of approach to development is not correct at this stage. Make sure you get to reach this this piece of code. It can be called of another method, or it can be anything. Math.max 542, for example, doesn't matter. This code is unreachable. Okay, so we saw that we can create methods that return values. We can develop our methods that return values the same way as math.max does, or any math class methods do. And we saw the rules. Rule number 1, you have to return a value. You have to return something. And rule number 2, based on rule number 1, you have to return the same type of thing that you declared on the signature, in the signature of the method. Rule number 3, make sure you do not have, make sure you remember rule number 1, and you do not have a case where your statement might not, where your method might not return anything, right? Compiler is going to help you with that. However, sometimes compiler can fail, so make sure to test your methods for all the cases you can think of, correct? So, and rule number 4, it has something to do with return methods and how compiler behaves. If in any case your after your return statement there is going to be a piece of code or multiple lines of codes that will not be reachable, then compiler is going to warn you and you will not be able to compile the code. Okay, so you have to return exact same type. You have to return and make sure that there are no logical flaws, that were logical cases where you might not end up returning anything. And 4, if you use return statement, watch out to have nothing after that, because then you're going to have dead codes. Having said all these, I want to thank you for your time, and I will see you in the next video recording where we'll look at more features that Java allows us as programmers when it comes to developing our methods, which will help us to customize our programs down the road. Thank you again for your time. I will see you then.